Hi guys, this is Vineet, and in today's video we will discuss about using execution plans to analyze the query behavior. This is the part 2 of this video series. If you have not watched the part 1 of this video, please go ahead and do so. The part 1 you will be able to find it under the SQL Server Performance Tuning playlist. The link is given in the video description for that playlist. Please check it out. So alright, let's continue. So guys, if you are new to this channel or if you are already watching videos from quite a long time and if you have not subscribed to this channel, what I would suggest is please go ahead and quickly subscribe to the channel. It will hardly take 5 to 10 seconds. So there's a subscribe button below this video. Please click on that subscribe button. It will give you some options or the bell icon. Click on that bell icon and select all notifications to get notifications regarding all my future videos. I will be posting few more videos or many more videos on in the performance tuning area in the upcoming days or in the next month. And if you would like to get the notifications regarding the same, please do subscribe. So let me give you 5 to 10 seconds. Please go ahead and subscribe now. So guys, I hope you have subscribed by now, and let's move on. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept. And if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or any production databases. And we would like to know your thoughts, comments, suggestions, requests regarding our videos. So please do share your comments with us. Also share any experiences with SQL Server, your day-to-day experiences with SQL Server, maybe in the performance tuning area or maybe in the other areas as well. Also do let us know if my content has helped you somewhere in any way. Do share your stories. We eagerly wait for them and would love to read them. Now let's move on. I've created some of the playlists for you to watch. Some of them are database design, tables, business continuity, indexing, performance tuning, and integration services. Please watch out these playlists as per your area of specialty or area you want to gain knowledge in. So this video belongs to the performance tuning category, so you can find it under the performance tuning category as well. There are other videos in the performance tuning category as well. Watch them as well. So why we create playlist is basically, otherwise so what you will do, you will go to my channel page and watch the videos randomly. So if you want to study in a proper manner, what I would suggest is go through a playlist. So for example, if you want to gain expertise in the performance tuning area, what I would suggest is go to the SQL Server Performance Tuning playlist and watch all the videos from beginning till the end to grasp a better clarity of each and every concept. So prior to this video, I've posted many videos on the performance tuning and my recommendation is to go through them before directly watching this video. Although you can watch this video directly as well, but yeah, it's better to begin from the start from the beginning. So I have a channel link page and we have links for all these playlists given in the video description area. So please check out the video description area. There are total number of 200 videos posted on my channel. This one is the 200th video. So this one is special. All right. And let's go back to the topic, which is we will show you how you can use the execution plans to analyze the query performance or query behavior. Now let's move on to notes. So today we will be, although we were discussing this topic previously as well in the part 1. So this is part 2 of this video. And let's begin with reading the topic, reading an execution plan. Like how you can read an execution plan. So that is the topic for today. And let me make it a heading if I have to write any notes within it in case. Alright, so I'm starting with the reading and execution plan area. So let's go to SQL Server and open up our query with an execution plan. So I've just invoked SQL Server waiting for it to open up. So earlier we had generated one of the execution plans for the query. So I will generate the same again as we wrapped up in the part 1 of the video. We were working on that plan. So I need to generate that plan again. So I'm inside SQL Server. Let's connect to a default instance of SQL Server, and I'm working with the AdventureWorks 2022 database. If you do not have it, please watch my previous videos to see how you can install this database. And let's open up query that we had saved earlier. So the query which I'm working on is the execution plans, and we have a query for which we will generate an execution plan. So waiting for query to open. So this is the query against some of the tables in the AdventureWorks 2022 database. Let's press the actual execution plan button to generate an execution plan. Now let's execute the query, and it will generate an execution plan for us as well. So which is in the execution plan area over here at the bottom. So this is the execution plan we were discussing previously. We had discussed some items regarding this execution plan like pipes and some of the operators. Now let's take this plan in detail. Now let's take another look at the execution plan generated here, right? Now, give me a minute, guys. I'm coming back. All right, let's start. So there are basically two ways to look at this execution plan. So logically, if we talk, plan is read like a book in English. All right. So we read plan like a book, right? From left to right. So we can start from left, which is the select operator, and go till the right. All right. So we can read the plan from left to right like a book. This means the first operator in the plan will be the select operator, right? In the upper left. Next would be the first nested loops operator, right? Following that would be the second nested loop operator, all right? And so on down the line. We read it like this. Like, so next will be compute scalar, and next compute scalar, and then next will be the index seek. So this is how you read the plan from left to right. All right, you go operator by operator from left till the right. Now you can also see that you can also see this represented in the node ID values for each operator. So each operator has a node ID value. Let's see if we have it in the properties section. It's not showing to me in the tooltip. So do we have any node ID properties here? I don't see any node IDs, but yeah, we will talk about it soon. Okay, let's ignore it for now. So for example, if we take the leftmost operator, in this case, which is select, all right, so we have selected the select operator over here. And now this operator contains metadata about the plan itself. So if we talk about just the select operator, it contains metadata about the complete plan. So if you want to check the metadata about the complete plan, just take a look at the leftmost operator. All right. So this operator will not have any. So if we talk about the leftmost operator, this operator will not be given a node ID. So the first node ID will go to the, so the first node ID in this plan would go to the nested loops operator. So we don't have any node ID assigned to the select operator because it contains all the information about the plan, and that's why the node ID information is not assigned to it. But if we go to the nested loops operator, we will see some node ID value in there. So you see this section. So this is the first node ID. So this is how you read the plan. So if you read the next nested loop operator, you will see it has a node ID 1. So we go node ID by node ID, right? So third node ID would be compute scalar, which has a node ID of 2. 2 means third. And this one is having 3, and this one is having 4. All right. So this was the node, and this was the node ID concept I was talking about. So it is not available with the first operator as it contains information about the whole plan. So that's why the node ID is not assigned to the select operator. But for other operators, the next one, we are starting with the node ID values. All right. So got the idea of node ID by now. I hope so. So, all right. Now let's move ahead, and if we talk about the logical reading of the plan, follows how a plan is initialized within the query. So if we talk about logical reading of the plan, right, it basically refers to how a plan is initialized within the query engine. All right. Each operator request. So I'm talking about each of these operators. So each operators, right, request data from those behind it. All right. So any of the operators request data from the ones that are behind them, right? In behind it in order until the data is found and returned through the rest of the operations. So each operator here requests data from the operator that is behind it. All right, we will show you how to read it, so don't get confused here. Basically, just get the concept that each operator requests data from the other operators that are behind them. All right, and this process follows till the end. All right, we will show you how to read it, so don't get confused. So we were talking about the logical flow, right, where each operator waits for the data to be given by the previous operator. Now the data flow on the other hand, now we are talking about the data flow. The data flow on the other hand starts from the, so logical flow is from left to right, but if we talk about the data flow, right, it starts from the far right corner if you see. So if you see the pointers of the arrow, so it's in the backward direction. If you take a look at this pipe, it is a backward pointing arrow showing you the flow of data direction. So it's from right to left, right? You see each fat pipe, or you see a pipe operators, their data is moving backwards from right to left. This is true for each of the pipes. Each pipe is flowing data from rightmost to the leftmost operator. All right. Okay. So the data flow, on the other hand, starts on the far right side and at the top of the execution plan. All right. So this will be the last step as per the data flow if we talk about, and this should be the first step. All right. All right. Let's move on. So that is what we are talking. So in our example, if we talk about, let's close this properties window. So if in our example, if we talk about the data flow, the index seek operator, which is the rightmost operator. So index seek operator against the IX underscore sales order header customer ID. So this is the index. The complete index can be figured out from here, from the tooltip. So it has IX underscore sales order header underscore customer ID, right? Index. So this is an index seek operator against the IX underscore sales order header underscore customer ID index. All right. So this is the first one. So this operator. So the first operation here would be index seek operation, right? Against the particular index we talked about, right? Now the first operator operates, computes its data, right? Then the data then flows back to this step, compute scalar. So the data then flows back to the left through the operators. So data flow will, all right, so let's talk about data flow. So data flow will go from index seek to compute scalar to next compute scalar to nested loops to another nested loops and finally to the select operator. All right, now let's talk more about data flow. So data flow through the operators depends upon the processing mode. So how the data will flow through the operators will totally depend upon the processing mode. And there are two kind of processing modes basically. One is the row mode and another is the batch mode, right? And we will get into the details of this later on, what is a row mode and what is a batch mode. But it is sufficient to say that row mode shows a single row being moved. Alright, so row mode is basically shows a single row being moved, while batch mode represents batches of rows being moved. So more than one, if more than one rows being moved, we can say that it represents the batch mode, where the batches of rows being moved, right? Now, these modes are why operators are sometimes called iterators. So they iterate through data either a row at a time or in batches at a time. All right. So if the processing mode is row, the operators iterate through the data in a row by row manner, or they can iterate through the data in a batch wise manner. All right. We will talk more on that, but just get the idea. Next, what we have to do, we have to interpret what operators are doing. All right. So far we have talked about the flow. So we are starting with this operation. If we talk about the data flow, it starts from rightmost and goes till the leftmost operator, right? Now let's talk on the next. What we have to do, we have to interpret what the operators are doing. All right. The description is a good place to start, right? So we can read out the description of an operator. So if we check the description of this operator, let's check on properties because it's easier to read. So if we read the description of the rightmost operator, it's in the description area over here. You can go through it. So this operator, index seek operator, scan a particular range of rows, from a non-clustered index. So this is what it's doing. So this is index seek for a non-clustered index, and this operator basically, it basically scan a particular range of rows from a non-clustered index. So this is what the description is, and the description is available for each operator. So for example, the compute scalar description says compute new values from existing values in a row. So it basically computes some new values from an existing values in a row. So this is what the description is. So we sometimes starts with the description area. All right. So description is a good place to start. For example, if we take a look at the description of the nested loops operator. So let's check the description of this. So it defines for each row in the top outer, input, scan the bottom inner input and output matching rows. So this operator performs some kind of matching, right? If you get the idea by the description. So the description is for each row in the top input, scan the bottom input and output any matching rows. So this is the description. Now the nested loop operators is one of the join operators. So this is equivalent to the join operator. So this is the inner join we used in the query. We use some inner joins. These are the inner joins. So nested loop is referring to that inner join operation. So nested loop operator is one of the join operations or operators, and there are three others that we will talk about later in our upcoming videos. So this one is the join operator. Just get the idea about that. Now a join operation, a join operation needs two set of data from two tables, right? So we need two tables for join, right? A join operation needs two sets of data, one from each table that it's pulling the information from. All right. So basically the role of this operator is to join two tables and get us the matching data, right? And this is why you can see that each of the two nested loops operator here. So we have two nested loops operator, right? So each of these nested loop operators have two inputs. So every time we use the nested loop operator or the plan use nested loop operator, it requires two inputs, right? So two inputs will be the two tables as it represents the join operation. The join operation then output the matching rows represented by the single output from the nested loops operator. So it gives us the matching rows from two tables. Okay. Got the idea, guys? And we will be walking through a lot more examples of reading the execution plans in the upcoming videos. Yeah, we are still discussing it here. So next question will be, what do you look for in an execution plan? So we have talked a little bit about how you can read an execution plan. We have shown you the data flow from rightmost operator to the leftmost operator, right? And we have talked about the nested loops operator, their description and what they do. They give us the matching rows. Now let's talk about what do you actually look for in an execution plan. So let me type that as next heading. So what do you look for in an execution plan, right? Let me make this another heading, properly color it maybe. Okay, now let's take it, this heading, this topic. What do you look for in an execution plan? So let's go back to the execution plan, right? Now it's cumbersome, we can say it's cumbersome and time consuming and probably impossible to attempt to read every single property of every single operator within an execution plan. So we cannot go through each and every operator and read every property of every operator, right? It is not possible and it's very cumbersome, right? So how to read a plan? That is the question. So it's very cumbersome, time consuming, and probably impossible to attempt to read every single property of every single operator within the execution plan. So instead, what do? We try to work with guideposts. So what are guideposts? Let me talk about them. Guideposts are some shortcuts that can help you make reading an execution plan easier. All right. The first time we look at an execution plan, we look at the following things. All right. So what are these following things? Let me write it down. So these are called guideposts, whatever I'm writing. So these are the items we look at first when we take a look at the execution plan. So these items are, let me type. So these items are, we look at the first operator. So let me make it a heading. So whenever we take a look at the execution plan, we take a look at the first operator of the execution plan. Okay. And let's talk about the first operator. So the metadata about the complete plan, the metadata. So what first operator holds? It holds the metadata about the complete plan in the operator itself. On the far left of the plan. So the first operator here is important. So in our case, the first operator is select operator. So this one is very important as it contains metadata about the plan execution, complete execution plan. It contains the metadata about that. The next thing, next item we will be looking at is the warning, any kind of warnings, right? So generally denoted by the exclamation sign symbol. Don't know if we have any in the execution plan, but let's see if we have any. So select has an exclamation sign, right? So it's a warning symbol kind of thing, right? So let's talk about that. If we talk about other operators, we do not see any warning symbols. But yeah, if we take a look at the select operator, it has a warning or exclamation sign. So this is what I'm referring to. So another important thing to look at is the warnings. So which is basically an indication of potential issues, right, with the plan. So exclamation sign or warnings indicate possible potential issues with the plan and are visually identifiable, right, indicated by exclamation sign. And we should then take a look at most costly operations. The third thing to look for in an execution plan is the most costly operations. All right. So let me make it a heading. All right. Third thing you would be taking a look at is the most costly operations. So these are basically operators with the highest estimated cost So operators with the highest estimated costs are likely to be the most expensive operators in reality. So if we take a look at our execution plan, what is the costly operator over here, right? What is the costly operator? So we can take a look at cost section. So this clustered index seek is using a cost of 59%. So this is one of the costly operators. Another cluster index seek here is using 33% cost. So this is another most costly operation. The third costly operation is here, which is using 8% cost. So the most expensive operation is this one. So we should definitely be looking at this highly cost operation. All right. So you got the idea, right? Now, next thing you will be looking at, so after looking at the most costly operator, the next thing you would be looking at is the fat pipes. So we talked earlier in the previous video. The fat pipes basically denote it represents the large data movement, and the thin pipe like this represents lesser data movement. So we should concentrate on the fatter pipes after we take a look at the costs. All right. So let me write it down. So next thing you will be reading in the execution plan is the fat pipes. All right. So let me make it a heading, guys. All right. So fat pipes represents, these are large pipes that represents data movement, or maybe large uh, pipes represents larger data movement. All right, we can say like this. Now next thing is the extra operators we should be taking a look at. So first of all, we will take a look at the operators with most expensive costs. Then we will take a look at anything extra. So what are these extra operators? Let's talk on that. So what are extra operators? So extra operators, so basically anytime you see an operator that you do not know what it is. So anytime we see an operator, like we see compute scalar operator and we don't know what it is. So these are extra operators. So anytime you see an operator that you don't know what it is or you don't know why it's there, it should draw your eye. So we don't know why the compute scalar operator is there, should be there for this query. So this is catching our attention. So these are the extra operators we should be taking a look at next. All right. So let me write it down. So it and these represents the operators that you don't know what it is. All right, what they are, maybe what they are, or you don't know why they are there, right? It should You should give attention to them. All right. So anything you don't know, you should definitely give attention to them after you take a look at other operators. So this should be in the sequence, right? All right. Let's talk about the next item we should be taking a look at is the scans. So what are scans basically? So the next item of interest is scans. Seek are not naturally good and scans are not naturally bad, if we can say. Alright, but scan do represents IO, which is frequently an issue. So by scan we are referring mostly to the index scan or the table scan, so which are basically IO intensive operations. Scans are basically IO intensive operations, we can say. Operations, we can say, where the whole table or whole index is scanned, right? So these are the scans we should be taking a look at, and as these are the IO intensive operations. So next thing we should be looking at the estimated versus actual counts. So let's talk about them. Estimated versus actual counts. we should be taking a look at. Guys, in case you need a copy of these notes, do let me know over to my email address. These are on the paid basis, 25 INR for a single page. In case you are feeling difficulty in writing the notes as I'm talking, so you may request the notes which will be paid in the form of PDF. So once I get your request, I will send you the payment link, and you can, upon making payment, you can download the notes. All right, now let's move ahead. So let's talk about the estimated versus actual counts we should be looking at. So when the actual values vary widely from the estimated values, it can be a sign of issues within the query. So let me write that. That is an important point. When the actual values, right, vary widely from the estimated values, it can be a sign of issues with the query. Now let's see if we get this information over here in the execution plan. So if we take this cluster index seek, so in the tooltip we see actual number of rows read, which is 22. And do we see any estimated number of rows? Check on this. Okay, so actual number of rows are 22. And the estimated number of rows to be read is 1 here. If you see the section, I can show you that in the properties instead of tooltip. So actual number of rows for all execution is 22, right? We can see the estimated execution, estimated stats are here. So estimated number of rows per execution is 1, right? This is where, so these are all the rows. So estimated number of rows for all execution here is, estimation is 20, where all the actual execution shows that there are 22 number of rows, right? So this is a little difference between the actual and estimated counts. So, but if we have a count that varies widely between the actual and estimated row count, then it can be a sign of issues with the query. Now let's take a moment and walk through these items which I have collated, starting from first operator till estimated versus actual count in detail. All right, and these are basically our guidepost, or these are the item we should be looking at. All right, so that's why they are called guideposts, or as the guide us basically how to read the plan. So we should be starting in order, and we will be discussing walk through these in a little more detail, so it's clear why we use this as guideposts. All right, now let's take the first operator. Let's take the first operator, talk about it more. So first operator holds the metadata about the complete plan in the operator, and it's on the far left of the plan. So in our case, it's the select operator, right? So let's talk about it. All right, let's discuss the first operator, which is the select operator, we can say, which is on the far most left hand side of the plan. So the first operator, the one all the way on the left hand side of the plan, contains metadata about the plan itself. Okay, so this operator contains metadata about the complete plan. Not all plans will have this operator. So every execution plan do not have this particular operator, right? So plans captured using trace won't have it at all. So if we use the extended events to capture the plan, we don't see this operator. All right. So plans captured using the trace won't have it at all. Plans captured using older versions of extended events may not have it as well. All right. Regardless, the data is still there in the XML. But the data is still there in XML, although extended events do not show this operator, but the data is there in the XML for the extended events. All right. It's just not within the readily identifiable graphical operator. But here we have used SSMS GUI, so we can see this operator, which contains information about all the plan, right? The reason we go here or look at the select operator is when we look at the so the reason we go look at the select operator is obvious because it contains information about the whole plan. And let's take a look at the properties of this particular select operator in detail, right? So go to the properties window. If it's not visible, you can right click on the operator and select properties to open up this properties window on the right hand side. All right, so I'm currently taking a look at the properties window. So we cannot go through all these in details, all the properties in details. Plus, we already covered some of the information gathered here in the previous video on query optimizations. Please go out and check the video on query optimization. So we will not cover all the properties here. We will cover some. However, let me point out a few places where you will look regularly. So let's take a look at places where we look regularly. So first is the cached plan size, which is 48 KB, showing up at the moment. It basically the cached plan size shows just how big this plan is in memory. So how this plan will take, how much space will this plan will take in memory is indicated by this value. So it is taking 48 KB in the memory. And the value for the query hash is considered a given query fingerprint. So do you see query hash over here? Yeah, it's right there, right? So if we talk about this column, this is the second column we should be looking at. So this is a query fingerprint basically. So the value for query hash is considered a given query's fingerprint. And this fingerprint can be used to search for similar queries. All right. So this is basically a query fingerprint. Let me write about query hash, otherwise you will forget it. So under first operator, let's talk about the query hash. So what is query hash? So query hash is considered as queries fingerprint, we can say fingerprint, and can be used to search for similar queries. So this fingerprints can be used to look at the search for any similar queries there and that are matching the pattern. All right, let's mark it with this color or maybe some other color which are more exhaustive. All right, so we talked about the query hash under the first operator. So query hash is considered as query's fingerprint and can be used to search for similar query. Earlier we talked about the plan cache or cache plan size value, which basically indicates the amount of memory the amount of memory this plan will take. All right, next we take a look at the query hash, which is a fingerprint basically, and this fingerprint can be used to search for similar queries. Now the same goes for the query plan hash. So first is the query hash, next is the query plan hash. All right, so this is the hash or the fingerprint for the complete plan, right? So this plan hash can be used to can be used as a fingerprint to search for any similar matching query plans, right? In the plan cache, generally used by the query optimizer. All right, and now let's talk about some of the set options here. So we have set options over here, right? Let's talk about them. The set options are the ANSI connection settings, basically ANSI connection settings, and differences here can result in different execution plans. So they are stored with the plan. So these settings, the ANSI settings are stored with the plan, and the difference in these settings can result in different execution plans. So they are stored with these values are stored with the plan itself. Now you can also see the query parameterization type, right? So let's see where it is. You can also see the query parameterization type, and when dealing with the parameterized query, the compile values, and if you have a runtime information for the plan, the runtime values. All right, so we don't see any. We see parameterization for statement. Let's see if we have a query parameterization here. Don't see any query parameterization values here. Though it's showing some statement parameterization type, I think this is the one it is referring to. So, all right. So this is the parameterization type. So the query is not using any parameters here, right? So we can see query parameterization type, and this section is useful, or this field is useful when we are dealing with the parameterized queries, the compile values, and if you have runtime information from the plan, sometime runtime values. Okay, let's ignore it for now. And sometimes we also see grant memory information to see how much memory SQL Server thought needed to allocate it for the plan. So do we see grant memory information? So we see cache plan size. We see some compile memory here as well. So memory grant information. Yeah, this is the area we are looking at, right? All right. So memory grant information, this section basically, we can see this section to see how much memory SQL Server. So we can take a look at the memory grant information section to see how much memory SQL Server thought needed to be allocated for the plan. So here it has not thought about anything. So that's why we are seeing zero value over here. Now, if you have the runtime matrix, you will also get the actual memory use. So we have taken the query with the runtime matrix, right? So do we see anything like actual memory use? We do see cache plan size. Do we see actual memory use here? Don't see it here, right? So actual memory use, maybe timestamp, CPU. Okay, it is not showing anything like the actual memory use, which is a great comparison point sometimes, but we are not seeing it here. We will talk about it in our upcoming videos. We are not seeing it here. All right. Finally, at the bottom section, we will see the warning section over here, right? And we should be taking a look at this warning section, right? So, which basically shows us the warning associated with this plan all in one place. So, what is warning saying? Warning is saying type conversion in expression. So, there is some type conversion happening. It is being converted, some value is being converted to n varchar 23, and the value is the sales order header ID, which is being converted to n varchar 23. And this conversion, it is saying, may affect the cardinality estimation in query plan choice. All right, so it is basically indicating a warning where some type of conversion is happening, and that may affect the cardinality estimate. We will talk about cardinality estimate soon, but yeah, for now, just take a look at this place. Where do you see warnings related to the given plan? So this is the area you should be looking at, right? All right. Now all this information describes how the plan was compiled, right? Its settings, and the rest is why we start here when looking at the plan for the first time. So all right, we shown you some fields what to be looked at while taking a look at the plan. Some of them are warnings, the cache plan size, the query fingerprints, and the query hash fingerprints, or the plan hash fingerprints, right? We can take a look at that. And yeah, that's pretty much it. Some of the items are having zero value, so not appropriate for our scenario. So fine, we are done with the first point or the first area, which is the first operator, right? We take a look at some fields which we have discussed a few minutes back. Now let's take a look at the warnings. We have just taken a look at the warning, right? So warnings are basically indicated by the exclamation sign, as we are seeing here, right? And we have seen the warning section, which is giving some type conversion type warning here. So warnings are basically indicator of the possibility of an issue that could affect the query performance. All right. And they are not automatically a problem, but they are an indicator of the potential for problem. So in our case, it is saying that this type conversion is a possible indicator of a problem, but it may not be a problem in itself, but yeah, it's a possible indicator of a problem. The plan we have been looking at has a warning shown here in the select operator, right? So we have read the warning as well. So this type conversion may affect the cardinality estimate in query plan choice. All right. Now the visual indicator lets you know that there may be an issue. So visual indicator is the exclamation sign which indicates warning. And the tooltip of the operator, if we take a look at the tooltip, at the bottom of the tooltip, we see the warning, the complete warning, which is saying type conversion expression, where the value for a particular column is being converted to nvarchar 23, may affect the cardinality estimate in query plan choice. Alright, so the tooltip of operator will show the warning, and you can see it in the properties window as well, as we have just shown it to you over here in this area. All right, so this is how to take a look at this is how you can take a look at the warnings. All right, and let's go into it further. So the warning is letting us know that, so if we just talk about this warning, it is saying that this type conversion which is happening can affect the cardinality estimate of the query plan, right? So warning here is letting us know that the data conversion operation is being run against a column, all right, which is the sales order ID column. Let me show it to you here. So conversion is happening against this column, the sales order ID, right? It is being converted into nvarchar 23, right? And this conversion may affect the row count estimates, basically cardinality estimates, and that will negatively affect the performance. So this conversion may affect the row count estimates, row estimates. It can affect the cardinality estimate as well, and it can negatively affect the performance. So this is the warning it is giving. Now this warning doesn't indicate that the actual problem exists. It just says that it could exist. So this is not the actual existence of the problem denoted by the warning. So it is a may scenario basically. So this is not saying that the actual problem exists, just that it could exist. All right. In fact, in this case, the warning is a false positive. So if we talk about warning in this case here, it's a false positive because the column in question is not used in any of the filtering operations. So filtering operation is the where clause. In the where clause, we have not used this conversion operation. So whatever it is showing in the warning, that conversion operation is okay. Let's take a look at properties. So, warning area. So it's a false positive basically. So we are not using any kind of conversion in the filtering area of the where clause, right? So it cannot affect the row estimates, all right, as the conversion is not happening in the where clause, so it will not affect the row estimate. So the warning is a false positive. And we will talk about these sort of issues in our upcoming videos as well. So just get an idea here, right? Now there is another warning indicator that we should be taking a quick look at. All right. So let's take another query for that. For now, let's save this query and close it out. We are done with this. Now we will show you another type of warning which is denoted by a different sign. So let me select some of the data from the table. Let's do a select star from purchasing dot product vendor is the table. Let's take it as product vendor. Okay. Now we are using one table. Let's use another table separated by comma. So let's take address from the person table, right? Let's take data from the person.address table. So we are taking data from two table here, and we have denoted this table, two tables with the abbreviations PV and A, right? And we are specifying the filtering criteria where a.city or person.address table city value to be, let's say Tulsa is the value. Now we don't want every column for this query, so let me select only some of the columns. So I'm selecting the on order quantity from the purchasing.product vendor table, and second I'm selecting the city from the person.address table. All right, so this is the query I'm executing, and let me take the execution plan. Let's take an actual execution plan for this query. Let's execute it. Now we got the actual execution plan. Now here you will, if you will take a look at the query, you see a different kind of warning symbol for the nested loops indicated by the red and white cross mark, right? Red circle with white cross mark. So this is another type of warning indicator that we should take a quick look at, right? So if we see any red axis, we should take a look at it quickly, right? Now if we look at the execution plan for this query, it is looking like this with the red circle with the white cross inside it. Again, we have to go to the operator with the warning in order to see the cause, right? So what is the cause of this warning? Let's take a look. Let's take a look at the property and the warning area. So if we go to the warning area of this operator, it is saying no join predicate. So here we have used two tables separately, but we have not joined these tables. So there is no join predicate, right? So this warning is very clear. We have no join predicate in the query. We have just fetched data from two tables without using a join. So this warning is straightforward, clear that we have not used a join in the query that we should be using. Now in this case, that's by design, right? So getting data like this is also okay. So that is by design. So we can see the error, right? So let's talk on the warning. Now, where's the warning, guys? I've lost the warning, right? For properties, yeah, now I see the warnings area. Okay. So in this case, that's by design. So we can see the error, right? You might have a query where you intentionally left off the criteria in order to get a Cartesian product result set. Everything joined to everything. However, it's also a possibility that someone just messed up, right? All right, so this is basically what I wanted to say. This is another indicator of some warning message, which is basically a red circle with a white cross. You can check out the warning area. So it is, the warning here is indicating that we have not used the join clause. Let's ignore everything else. All right. Now, there are a number of other possible causes for warnings. They will all show up as either as exclamation point or the red X. So these are two signs for the any of the warnings: the exclamation point and the red X, which you should be taking a look at while when you read the execution plans. Now we are done with this. Let's talk about the third point. So we are done with the warning section. Now let's take a look at the most costly operations in the query. All right. So let's take this query as an example. Do we have any costly operation over here? Yeah. So if we see here, we have a 91% cost showing up here for a index scan, right? Index is also given over here. It's a non-clustered index, and the index name is ix address line, right? Address line 1 underscore address line 2. This is a bigger index, so it is showing us that index scanning is happening, which is a costly operation, and it is using a cost of 91%. All right. Now let's take a look at most costly operations. So here we have index scan, right? Now, even though the cost of the operators are all estimates, so these cost the 91% or the 3% below is an estimate basically. These are, although these are an estimates, these are solid numbers that the optimizer uses to make its decisions. All right. So these numbers, cost numbers, are used by optimizer to make its decisions. Therefore, they become the driving factor behind our interpretation of the execution plans. All right. Now, if you take a look at the execution plan for the query we used to generate the warning earlier, you can see that the index scan against the IX. So if we take a look at this, give me a moment, guys. All right, guys, let's resume. So what we were talking about is, now if you take a look at the execution plan, right, we can see that this bigger index, which is IX, address line 1, address line 2, city, state, province ID, postal code, we are doing an index scan on this, or the optimizer is doing the index scan on this index instead of index seek. All right. So this operator has a higher cost so far in this plan. So it has 91% cost, right? All right. Now, the processes that cause more IO generally also cause queries to run slower. So this is an IO index scan is an IO intensive operation. So that will cause our query to run slowly, right? Because it is IO intensive. Generally, we prefer index seeks instead of index scanning, right? So as a general point of rule, the processes that causes more IO generally also cause queries to run slower, right? The estimated cost associated with this index scan is the most likely place to focus our efforts if we want this query to run faster. So we should focus on this area where 91% cost is showing up. So we should focus our attention here, right? If we want our query to run faster. Now remember, while an estimated cost may be high, it's still just an estimate. You may find that the real culprit for slow query performance lies elsewhere. So even though this operator is showing the highest cost, there may be a possibility that the real culprit not lies in this operator but in some other operator. All right, there is a possibility. So these costs are basically what I'm trying to say. These costs are just estimates. All right. So we talked about the most costly operation. So in this case, index scan is taking the most cost, and which is 91%, and we should definitely focus our attention here. Now let's talk about the fat pipes. The next one is all the fat pipes, right? Let's talk about them. All right, so we're done with most costly operations. Let's talk a little bit about the fat pipes. So since the pipes basically here, if you can see, this pipe is very fat pipe, you can see, compared to this pipe, right? You see the difference here in the size. It's this one is more thicker, representing larger data moment, right? All right, so since the pipes represents the data moment, identifying large amounts of data moment can help us interpret an execution plan to identify the most likely cause of performance issues. So basically, if we have a fat pipes, we should give our attention there. So here we have a fat pipe, right, which is moving out a large number of data, right, which identifies large amount of data moment. So here it is indicating large amount of data moment. This can basically help us interpret an execution plan to identify the most likely cause of performance issue. So this may indicate a performance issue here, right? Another thing we look for when looking at the pipes is transition, either from fat pipes to thin ones or the reverse. So here we have a transition. Here we have a fat pipe. Then the next operator is using a very thin pipe. So the area we need to focus on is here, right? All right. Now let's move ahead. So we do see some scenarios where thin pipes become fatter at the end and the fat pipes become thinner at the end. We can see both the scenarios. So in the first case, so here we have even size for a, give me a minute, guys. All right, guys, let's talk about fat pipes. So you see a difference in size of these pipes. This one is thicker and this one is thinner, right? So let's talk about the fat pipes topic, right? So basically, large pipe represents or thicker pipe represents the larger data movement. Since the pipe represents the data movement, identifying large amounts of data movement can help us in interpreting an execution plan to identify the most likely cause of performance issues. So let me write this point down. So large pipes, or maybe I can use the word thicker pipes, represents larger data movement. Okay. And basically, I would say, and identifying large amounts of data movement can help us in interpreting an execution plan to identify the most likely cause of performance issues. So we should focus our attention on fat pipes as well. Another thing we look for when looking at the pipes in transitions. So another thing we take a look at pipes in there are certain pipes in transition. Here we don't see any pipes in the transition mode. So what is transition? Basically pipes in transitions. So if a pipe transits from a fat pipe to a thin one, or the reverse can also happen. A thin pipe can grow into a thicker one. Here the size is constant, so we do not see we see a static size, right? Not a thin pipe is suddenly changing into a fatter pipe, or a fatter pipe is not suddenly changing into a thin pipe. So sizes are constant over here, right? And we can also see situations where thin pipes are growing fatter, but here we do not see any situations. So if we talk about the first case where fat pipes are becoming thinner, although we don't see that case here. So if we see such a case where fat pipes are becoming thinner, you are seeing late filtering of the data basically. All right. So I think it means that we don't see pipes like this where the back is thicker and the front is smaller, thinner. But instead you see this transition. I think this one is thicker and it is transiting into the thinner pipe. So this one is thicker, this one is thinner, right? So this is the transition which is happening. So this operator is providing larger amount of data to this operator, whereas this operator is doing a join and reducing the amount of rows, and data has become lesser, and finally outputting that data to the select operator. All right. So I think this is a transition. So we are talking about the first case where the fat pipes becoming thinner. So I think this should be the case, fat pipe becoming thinner, right? So it basically indicates that we are seeing late filtering of the data. So filtering is happening here, right? And then we have a less amount of data here. Whereas this operator has passed larger amount of data to the inner join operator or nested loops operator. So it's possible that an index could help, or maybe some changes to the code. All right, where we see a larger amount of data being pushed through. Now in the second case, where we see seeing data being multiplied as the execution of the query progresses. So in some cases we see reverse situation as well. This thinner pipe is coming over here, and we see thicker pipe over here. If we see such a reverse situation, uh, reverse compared to the situation we are seeing here, right? So in the second case, if we are seeing data being multiplied as the execution of the query progresses, again this increase in data movement means more IO and more memory resources being used. So if suddenly we see a thinner pipe is changing into a thicker one, all right, what that means is more IO and more memory resources are being used. All right, and this may be a place where adjustment to code are necessary again. So we will talk about some example later on, but yeah, till then, keep this idea in mind. So wherever we see thickness in data, we should check out the code of our query. All right. So all right, let's move ahead. And the next topic of interest is the extra operators, which is another guidepost of area of interest in reading the execution plan. So what are extra operators? So earlier we talked that the operators that you don't know what they are or don't know why they are there, and they should we should give attention to them. All right. So here in this query, are we seeing any such operators? Most of them are known to us, right? In earlier query, we have seen some operators which are compute scalar operators. So let me open up that query. Here, all of the operators are familiar to us, so don't make any sense to talk about extra operators here. So let me open up another query which we were using earlier. So that was the executing plans query. Let me execute this query with an actual plan. So here in the execution plan, in this plan, we are seeing some operator compute scalar, and we are not aware of what the meaning of those operators means, right? So basically, first of all, we can say that there is no such thing as an extra operator. So there are actually no thing such thing as an extra operator. However, we needed a shorthand way to describe the situation where we need to investigate the given operator because you have a lack of knowledge. So in reality, extra operators do not exist, but yeah, we are just referring to using the extra operators term to refer to any of the operators which are not looking familiar to you. So it's just that, all right. Or we have to investigate if we want to if we have to investigate a specific operator for which you are not familiar. Those are all called the extra operators. You can call them extra operators, although this is not a standard terminology for this. Now, if you don't know what the operator is, that should be one that draws your eyes. So here we don't know what compute scalar is. So this should keep our attention or draw our eyes so that we can better understand how the query is being processed. Now, if you don't know why a given operator is being used in a particular situation. So for example, in this query, if we take a look, we are doing join on two tables and finally fetching out some columns. So we don't know here why these compute scalar operations are being used. All right. So if you don't know why a given operator is being used in a particular situation, that can also be a signpost of further investigation. So here we don't know why the scalar operators are used, compute scalar operators are used. So this should be the area of investigation, right? All right. So we are in this query and we are looking at the execution plan. So earlier we discussed about all the other operators, the nested loop one, the select one, and give me a minute, guys. So guys, we earlier we had talked about all the other operators, including the select one and the nested loops and the clustered index seek operators as well. But we had not discussed about the compute scalar operations. So let's discuss about them. All right. Now guys, since we don't know what a compute scalar operation is, this represents an extra operators in this case, right? And if we look at the description of the operator, we get the definition of what it does. So if we take a look at its definition, right, it says it computes new value from existing values in a row. All right, so this is the definition of this operator. So it computes the new value from an existing values in a particular row. It computes new values from existing values in a row. All right, so we have just taken a peek at the description of this operator, compute new values from existing values in a row, right? All right, let's move ahead. But now we are still faced with these being extra operators since we don't know why the operations are being done. So far we have looked at what it is doing. So it is computing new values from existing values in a row, but we are still not aware of why these extra operators are being used, right? Now, second, the selecting the second compute scalar operation, we can look at the properties. So let's take a look at the properties of the second compute scalar operation. Let's see what they are, guys. All right, guys. So we have opened the properties for the second compute scalar operator over here. Let's see what do we have to check in that. So let's take a look at the properties to understand what it is doing. So let's expand this defined values, intrinsic, scalar operator, and there's one, two, arithmetic, constant, scalar operator, one, two, constant, this, scalar operation, identifier. All right, I've expanded all the items. All right, so this is what it is doing. So we have fetched the details, right? So what all of that is showing is a bit of a T-SQL code. All right. So let's see where the T-SQL code is. So we have code over here. So this is the code. If you take a look here, this is the code, right? So if you take a look at the second line, right, and click on this. So this is the code that is being executed. So it's a bit of T-SQL code. And if we look at the structure of the tables here, right? So tables which are being used are sales order header, the sales order ID column from the sales order header, right? So if we take a look at the structure of the tables, we will find that the sales order header table contains a computed column. All right. So why this compute scalar operation is happening, right? So this is scalar operator. This is happening because it is using this sales order header table, right? And that sales order header table. So let me show you here on the left hand side. So if we expand that, so we have a sales order header table under the, let's see the schema. So it's under the sales schema, the sales order header table. Let's go into that and let's little bit reduce the properties size. So sales order header. All right, this is the table, and if we expand the table, right? So if we look at the structure of the table, right? What we will find? We will find that the sales order header table contains a computed column. So if we take a look at the columns here, right? So what is the computed column here? If we take a look here, so sales order number is the computed column here, right? So we are selecting this column, right? So this is what is causing the scalar computation or this operation to execute, because this uh, column is a computed column. So if we take a look here on inside the bracket, what we will see, we are seeing that this is a computed column, right? So if we look at the structure of the table, we'll find that sales order header table contains a computed column which is sales order number, which we are selecting in our select query right here. So this is a computed column. All right, and that T-SQL is the calculation necessary to generate values for that column. So what is that T-SQL? So if we look at the T-SQL here, right, inside this, right? So we take a look at T-SQL here. It is basically necessary to generate the values for that column, which is a computed column. So that's why the scalar operation is happening. Now, not only have we answered most of the questions about these operators, we have also identified the source of the warning from earlier in this chapter, right? So we were talking about this warning, right? So some conversion is happening, right? So we were talking about this warning earlier. So this is the cause of that warning. Some scalar operation is happening. All right. So this is the cause of that warning. So let's move ahead. So what we were discussing over here, why the scalar compute skill, these extra operators are here or compute scalar operators are here. You can check out the code that is executing right from here, right? All right. So let's take a look at code here. So this is the scalar operation that is happening, right? And that is happening because of this column, sales order number, right? Which is a computed column. So that's why the scalar computation is happening. So keep in mind till this point. All right. Let me close the properties and let's talk about the next topic, scans over here. So what are scans? Scans are basically IO intensive operations. All right. Scans are basically IO intensive operations where the whole table or whole index is scanned, right? Either we can talk about index scanning or the table scan in case the index is missing. All right. So let me talk a little bit more about that. So scans are the signpost for us simply because they represents the data movement. So scan is basically a scanning of table and they also represents the data movement. And the more data movement means more disk and more memory access. And this is frequently the cause of performance problems if scan are happening. All right. So let me write that down. So scan basically represent the data movement. All right. So more data movement, if there is more data movement, that means that more disk and memory access is required, right? So if we need more disk space or more memory access, this is frequently the cause of performance problem. So whenever we see that index scan or a table scan is happening, that is a cause of performance problem and that should be catered to, right? So that should be resolved. If there are any table scan or index scanning is happening, we should be taking a look into that. Now let's go back to SQL Server. So let's take another query. Let me close all these out. Let me also collapse this. Now we will write a simple query against AdventureWorks table. Let's write that query. You may write that along with me. So we are doing select star from, let's say, production dot unit measure as So let's take an actual plan for that. So basically, first of all, let me tell you, if we look at this query, the only way the query can be satisfied is through a scan. All right. Because without any kind of filtering criteria, we are not using any where clauses here, right? So without using any kind of filtering criteria, the optimizer can only choose a scan. All right. So the thing is, if we don't use any where clauses in the query, the optimizer can only choose a scan. So that is one of the important points to be noted. So that is under the scan. So if we do not use any filtering criteria in a query, the optimizer can only choose a scan. So that's why I was saying that this is a simple query without using any where clauses, right? So if we take a look at the actual plan of this query, if I execute this query, we can see only table scan will happen because there is no where or the filtering criteria. So let's see the execution plan of this query. So let's take an execution plan. So here you see index scanning is happening. So it's not a seek, it's a scan, right? Index scan. And ideally we should avoid it, but for this simple query, optimizer will only choose a index scan and not a seek because where clause is not defined on this query. All right. Now, without any kind of filtering criteria, then an optimizer can only choose a scan. A seek in this case would actually run slower than a scan. So in this case, scan is preferable. That's why optimizer has chosen scan. So if the optimizer would have chosen seek for this case, or an index seek for this case, that would actually run slower than the scan. All right, and we will discuss about that reason later on in our later videos. For now, I think you got the idea why the table scan will happen, because the where clause is missing, and scan is better in this scenario rather than index key seek. So that's why the optimizer choose the index scan. All right. So scanning topic is done, guys, and let me take you to the next topic, which is scan is done. So the last topic is estimated versus actual counts. So when the actual values vary widely from the estimated values, it can be the sign of the issues with the query. So yeah, let's ignore this definition for now. So let's go inside SQL Server. So when we execute a query and capture the runtime matrix, so here we have executed this query in the actual by including the actual execution plan, which basically also include the runtime matrix as defined by the number of rows present in the operators. All right, so it is showing 38 rows. Now, when we execute the query and capture the runtime matrix along with the execution plan, we can add one more signpost to our list, which is basically the actual plan. Basically, we can, when we take the actual runtime matrix, we get a facility to compare the estimated values and the actual values of the operation. Now, okay. Let's see the performance plans of previous query. Let me open them out. Give me a moment, guys. Let's take an actual execution plan for this. So, do we see any? So let's talk about this operation, right? Clustered index seek. So it's not a scan; it's a seek operation, and it's seeking a cluster index, right? It's taking a cost of 59%. And it is working on the 22 rows, 22 of 28 what is what it is saying, right? So this is one of the costliest operation in this plan, right? So it is having a very most of the cost is consumed by this operator, so it is using 59%, right? Okay, so all right, let's take a look into that. So this operator is using the 59% cost. All right, so this is the costliest operation within the plan. The cluster index seek against the pk underscore product dot product id index. So you can check the index on the right hand side. So it is working on the pk underscore product id index, right? So it is doing a index seek on that particular index. All right. So we can see immediately that estimated number of rows to be processed. So we can take a look at the operator details. So we can see that the estimated number of rows to be processed by the operator was 20. So written at the bottom side, you can see this, the bottom line of this area. So the bottom line of this area is indicating 20, right? So which is equivalent to the estimated of number of rows to be processed by the operator, which was 20. Whereas the actual number of rows, which you can find in the second last line, 22 of, right? So the actual number of rows was 22, which is actually 110% of the estimated rows, right? Which is 20. In this case, that's not far enough to give us a concern, because the gap is not very wide. So 20 and between 20 and 22, there is not much wide gap. All right. So in this case, that's not far enough of to give us a concern, right? In fact, we would not worry until we are seeing at least threefold or more increases. All right. So until we see a gap of like threefold or multifold or more than that. All right. So we should worry only in the situation if we see at least like a threefold or multifold gap, more than threefold. or conversely 1 by 5 or fewer decreases in the comparison. Alright, those aren't hard numbers, just general examples. Alright, so we can get more comparison by looking at the properties. So let's take a look at the properties of this operator. Let's expand on the properties, keep it to the right, left. Let's take a look at the properties. We can do more comparisons over there. So let's see. Now we can see row estimates over here, right? In this section, which is coming in this estimated section. So if it is saying estimated number of rows for all execution is 20, right? All right, so we can see row estimates again here along with the actuals. Actuals are given over top, right? So this is the actual number of rows, 22, whereas the estimated number of rows are given here, which is 20, right? But let's see something with more disparity. All right, now if we take a look at the estimated rebinds, so take a look at this column, estimated rebinds, which is 19, right? And compare that to the, so estimated rebinds is 19, and if we compare it to actual rebinds over here, which is 0, right? So there is lots of difference over here. So 19 compared to 0 actual, 19 estimated compared to 0 actual rebinds. All right, and we are discussing exactly what a rebind, so we will discuss later on what a rebind is. All right, but you can see that in this case what the estimated is not what happened, right? So we will talk about what the rebind operation later on in our videos, but just for the sake here, I'm telling you, we see a huge difference in the actual values and the estimated values. So you should be looking for these values. Later on we will talk about rewind, so you should stay in tune. Guys, if you are new to this channel, please, if you have don't subscribe to this channel, please go ahead and do so. Please subscribe to this channel immediately. So that you can get alert regarding my future videos. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon. It will give you the options. Select all notifications to get notifications regarding all my future videos. Please go ahead and do so. Let me give you 5 to 10 seconds to do that. Please go ahead. Alright guys, I think you should have subscribed by now. So I was telling you the difference between the estimated value and the actual value. Sometimes the difference is far more, and that we should take a look at that difference, right? So here we have a huge difference between the estimated rebinds and the actual rebinds, right? 19:0. So guys, we will discuss about the rebinds later on. All right, but we can see in this case what the estimated is, not what actually happened, right? And the disparity could be a strong indicator for all sort of performance problem. So in this case, we have a huge disparity, huge difference. So the disparity could be a strong indicator for all sort of performance problem, which is why we will use this type of comparison as one of our guideposts. So difference. So what was the guidepost? So guidepost was this estimated versus actual count. So whenever we take a look at the plans, we take a look at the estimated versus actual counts. So that's the one of the good guideposts. So that's it guys. So what are the guideposts we have discussed while reading an execution plan? So we have discussed about the first operator we should be looking at, any warning signs, then an exclamation symbols, or the red circle with white cross, and we should take a look at most costly operations. We should take a look at fat pipes. We should take a look at extra operators, why they are being used, and we should take a look at scans. Basically they occur when the where clause is missing in the query, and sometimes it's better to have a scan rather than index key seek, right? And we should take a look at estimated versus actual count. So we should see the difference. So these are some of the important factors we should be taking into account, or basically the things we should be looking at in the actual execution plan. to read it properly and to get an idea what is going on. Now let's discuss what's after the guideposts. So what do we do after the guideposts? So let me discuss on that. So let me write the topic what after guideposts which were given above, right? Let me make it heading. So what things we should take a look at after we have taken a look at the guidepost. This is what I'm discussing here, right? So first of all, we can use these guideposts, these 1, 2, 3, 4, 5, 6, 7 factors, right? First, we should take a look into that. And once we are done with that, so first of all, we should use the above guidepost quickly to identify any potential issues, right? So guys, we should use guidepost to quickly identify any potential issues first, right? Within an execution plan. And this is especially helpful the first time you look at the given execution plan. So first take a look at them, right? And however, these only carry these things, the guideposts will take you only so far in understanding what is going on within an execution plan. So after looking at these guideposts within the execution plan, so you should get an idea by this time what is going on in an execution plan. So if you take a look at the guidepost, right? So after you have exhausted the simple process of using the guidepost, what you need to do next, do the hard work of understanding what's happening in the plan, where the guideposts don't give you enough information to go on. So sometimes these 7 things, the first operator warnings, most costly operation, fat pipes, extra operator scans, and estimated versus actual counts. When we have gone through all these, sometimes it doesn't give you much information or enough information to go on further, right? So first of all, get in the habit of tracking the node ID value for the operators. So first thing in the execution plan is you should track the node ID values. So here to know the sequence. So this operator has a node ID value of 0 and we are beginning here basically. The second operator has node ID value 1, right? So first of all, we should get in the habit of tracking the node ID values for the operator. So let me write it down. So let me copy something. Okay. First of all, track the node ID value for the operators. Okay. So track the node ID values for all the operators. So why that is useful? Why tracking node ID value is useful? Knowing what the node ID is. So basically why they are helpful. If you knowing what the node ID is lets you know the order in which the operators were instantiated or processed, we can say. All right, so basically node ID gives us the idea about which operators will execute at what time. So this node ID with the value 0 will execute first, and then this particular operation, the second nested loop or inner join, this will execute next. So it will basically tells you the idea about the order of processing, right? Order of instantiation of a particular operator, right? Let's go back here. So it lets you know the order in which the operators were processed or instantiated. And it also it helps us in helping you understand how the query is being processed. So once we are done with the guidepost, we should take a look at the things after. So first of those things is node ID value for the operators, and that will basically help us in determining the order of execution of the operators. All right, and they will also help, the node ID values also help us in understanding how the query is being processed. All right, and we will also run into operators that refer back to the other operators. All right, so keeping an eye out for references to other node ID values help you understand the execution plan. So in some cases, we see operators that refer back to the other operators. So those have a column of, I think, reference node ID. So we should keep an eye out for references to other node IDs values, help you understand the execution plan. All right. So this is the sixth operation. We can see it has a node ID value of 6. All right. Uh, Let me move back to notes. All right. So next, get in the habit of tracking the output of each operator. So first thing we should track is the node ID value. Next, get in the habit of tracking the output of each operator. So we should check the output of each operator as well, right? And many operators change or add columns to the result set. So let me note that down. So many operators change or add columns to the result set. So there are certain operators which can change or add columns to the result set. So basically knowing where these columns come from can be helpful in understanding the plan. So sometimes certain operators do add certain columns to the output. So we should understand where these columns are coming from. So we should get in the habit of tracking the output of each operator. All right. So finally, let's talk about last habit. So finally, if we talk about get in the habit of early of using the properties of the operators. So we should be checking properties of the any of the operator in the properties window. So that's very important. So we should check the properties of the operator. So you should get in a habit early of using the properties of the operators. In some cases, the information you need immediately is on the tooltip. So why we should check the properties of the operator? So if we talk about some cases, so in some cases, the information we need immediately is in the tooltip, right? So sometimes we get the information we require or we require immediately is available in the tooltip. However, frequently it's not. So, however, if we talk about general situations, frequently it is not. All right. Sometimes the information is not available in the tooltips. So having to get the so we can say to get the more complete picture at your fingertips. Complete picture, I means having information about all the properties, right? For a particular operator will help you read and understand execution plans in a better way. All right. So we are done with this. What are the things we should be checking after taking a look at the guidepost or the important items? We should take a look at tracking the node IDs. We should get in a habit of tracking the output of each operator. And finally, we should get in a habit of checking the properties instead of just taking a look at the tooltips. All right. So guys, let me see if I should cover the next topic in this. So let's talk about some of the tools that assist us in that assisted that basically assist us with the execution plans. So tools for execution plans, let's discuss on that. All right, so let's discuss on this topic. Let's talk about this. So this is the heading, tools for execution plans. So the more you get into reading the execution plans, the more the need to have a little help in navigating and understanding the plan becomes useful, right? So the first tool we are talking about here is, so the first tool I want to recommend to you is, okay, give me a second guys. So guys, I will be soon coming out with the series just on the execution plans or the SQL Server execution plans, how to read them. So we will talk about what the execution plans in that series I'm talking about, which will release out soon, right? It will not be a part of this series, but yeah, I will be coming up with that series soon. So in that series, we will talk about what the execution plans are and how they work and how to basically interpret them in more detail. So in that series, we will just be covering the execution plans, but we will not be covering any kind of query tuning in that. But yeah, in this series, we will be covering the query tuning process. But in the upcoming series on execution plans, I will be just covering the execution plans only. All right, so let's come back to the topic. So we were talking about the tools for execution plans. So first tool we have is the SQL Server Management Studio, right? So let's discuss some couple of points or some of the points immediately about SQL Server Management Studio. And as you're likely to be getting a lot of your plans through extended events, querying the DMVs or querying the query store, you are naturally going to do more work. You are naturally going to do more work with plans in SSMS. All right. So in the upcoming videos, we will be getting a lot of our execution plans via the extended events and the DMVs and the use of query stores. So we will be doing most of our work in SQL Server Management Studio. So understanding how it can help will make execution plan reading easier for you, right? So let's discuss few of the points here and then we'll get into some of the detail, right? And first you can simply drag a plan around on your screen by clicking with your mouse. So yeah, we know by now that we can drag a plan like this to keep certain operator, giving the focus to a certain operator. We can drag the plan. Everyone knows about this, right? Like this. All right. So first thing is we can simply drag a plan around on the screen by clicking with your mouse and then dragging. It will move the plan around. We can also zoom in and zoom out on the plans. So sometimes there are a zoom in and zoom out button options are available. So if you want to zoom in, you can zoom in like this. Right click, do a zoom in. So it will max out the plan. So if you want to just concentrate on this operator, it is giving you a more larger view. And similarly, we can zoom out as well by right clicking in and zoom out, right? So you can zoom in and zoom out like this. So other way we can zoom in and zoom out is you can hold down the control key and use your mouse trackball. So control scroll is the way here. So you hold down the control button and use your mouse slider or tracking wheel to zoom in and zoom out. You can do it like this, right? So that is also an easy way to zoom in and zoom out. Otherwise, right clicking and selecting zoom in and zoom out. All right. And finally, for plans that are exceeding the size of the screen, there's a small plus sign that will appear in the lower right hand side corner. So if the plan is very big and it cannot fit the screen. So sometimes we get a plus sign over there, right? On the bottom right side of the screen, right? And clicking on that plus sign will open a small screen sometimes, right? Which we'll see maybe in some upcoming videos. But yeah, this plan is fitting within the screen, so we are not getting any plus signs or anything like that to see the plan in a smaller window or another window. While you can drag a plan around on your screen, this enable you to simply drag the view of the screen around the plan. So what I was talking about, the plus sign over here, is once you click on the plus sign, it will open up a new window, right? And in that window, basically you can that enables you to simply drag the view of the screen around the plan. So once we see it, we will show you. Right now it is not coming. So all right, it can be useful if you're not sure where to go on the plan, since it gives you a full view of the shape of the plan, so you can decide where you would like to move the things. Right now I think this is sufficient, so let's ignore it for now. All right. Now after that, we will also get into the more detailed functionality of the execution plans within the SSMS. So another functionality is the find node functionality, right? So what is the find node functionality within SSMS? Let me write that down. The find node functionality within SSMS. So what is find node functionality? So when execution plans become very large, right? This one is even I would say small. Sometimes we do get very large plans, right? Tracking down a particular operators can be much more difficult. So if we have a very large plan, so it is difficult to track particular operators. So it is difficult to track, right? And so at that times, what we can do is we can use the find node functionality within a plan to search for a particular node. So how to use that functionality? So right click within the plan, right? And select there is a find node button. So it opens up this small section over here, right? So here we can search for any particular item, right? And we can use the first drop down to pick all list of possible properties, right, within the current execution plan. So this is the all the properties within the plan, right? So we will show you shortly how to use this. But yeah, these properties can be used to find out a particular node. All right. So here we have a property with the name estimated rows as well. So let me see. If we have estimated rows, yeah, here we have estimated rows. All right. So selecting one of the property means you will be searching for values within that property. So it's basically property search, right? So estimated rows is properties for maybe one of the operators. And we can search only one property at a time. And the next drop down, basically, if we select estimated rows, next drop down gives us the exact search, which is done by equal to, or we can take contains to get the similar to like operator. So if a particular property contains certain value, we can use the contains keyword as well to search for a particular property value, right? Now we have two choices, equals and contains. Now in other words, you can search for a specified value or do a loose match using contains. No wildcard replacements necessary when we are using the contains option. Now there are two arrows pointed left and right. So what are the purpose of these arrows? That will help you in moving you through the plan to the operators that match, highlighting those operators that are satisfying the filtering criteria. All right. So let's say if we take estimated row contains 3. So wherever there's a 3 written in the estimated rows, it will takes us to those operators. So let's do a right arrow search. So it takes us to the took us to the which operator? compute scalar. So we can do next as well. Second compute scalar it took us to. Next is it took us to the index seek operation, right? So if we take a look at the properties, the estimated number of rows, if we say it contains the value 3, right? So take a look here in the tooltip. So estimated number of rows, it is showing that it contains 5.3 or the number 3. So that is what is showing up it contains. So we can search like this, right? And we can move through search like this. All right. So we did a search for any operator where the estimated rows contain the value 3, right? The indexic operator estimate was 5.3, so 3 was included within that, right? It is included within the 5.3 value. All right. So this is how you can do a search within a particular plan. So you can use the find node functionality from here, right? You can cross it out as well to close it. Again, open it. You can do it through find node, and yeah, if you want to close the find functionality, you can close it from here. All right, guys. So next feature is the compare plans, where you can compare two plans. So yeah, let's discuss on the next feature, which is compare plan functionality. So these are all the functionalities within the SQL Server Management Studio. So next functionality we are discussing is compare plans. All right. Okay, guys, let's talk about how we can compare some plans. Let's talk about this topic. So you can compare two execution plans and find all out their differences and similarities using the SQL Server Management Studio. So basically, execution plan, the compare plan facility is available to compare the two execution plans to find out their similarities and differences, and this can be done within the SQL Server Management Studio. And one of the plans must be saved as a file, right? So we want to compare two files, then compare two plans, then one of the plans should be saved in a file. And you save a plan to a .sql plan file by right clicking on the plan itself and choosing the save execution plan option or save execution plan as option from the context menu. So let me show it to you. So if I suppose, for example, execute this query with an actual execution plan, which is basically turning on this button to get the execution plan. So we got the execution plan. So in case I want to save this plan to a file, I need to right click on this and there's an option to save execution plan as. All right. And it saves the plan as SQL plan file, and you need to give the name of the file. So I had already saved one of the execution plans. Not sure whether I will use it, but yeah, if you want to name the file, just name the file and save it. It will save your execution plan. Alright, so this is the context menu option. You can use save execution plan as option to save any execution plan. Now from the plan that is not a file. So right now this is a plan which is not a file. Alright. We can right click on the plan and do a compare plan, select the compare show plan option from the context menu to compare this generated plan with an existing plan which can be present in a file. So if we click on compare plan, compare show plan, it gives us the option to open up a SQL plan file. So to be compare this plan against. All right. So all right, we have selected showed you the compare show plan option, and we got the window to select the SQL plan file. So let me, for example, let me compare. Give me a minute, guys. Okay, guys, in order to do a comparison, let me save this execution plan in a file, and I will compare the same. Compare this execution plan against the one saved in file. So let me save it in file. I will compare this plan against itself. So there will be all similarities only. All right. So let me save the execution plan as maybe test plan. Let me save it as test plan and do a save. it will save the plan in the SQL Server Management Studio folder under Documents folder. So plan is saved. Now, right now, if I want to compare the plans, this is just a fake example. So don't consider as an actual example, but right now I'm just showing you how you can use the compare show plan utility. So I've selected a compare show plan, and I want to compare the existing plan which is showing here with the test plan which I've saved in a file. So
Connected to Planets Fire TV.
let me select the test plan. So you see we got the comparison window. Um, Let me close the bottom ones. These are the properties windows for both the plans. All right. And in the top and bottom section, we see the same plan being getting compared. All right. And we can compare the property windows of two plans if we really want to make comparison between the two plans. All right. Now, let me go ahead and check what should be done next. So this is how you compare the plans, and now basically that's hard to see. So we cannot see all the plan in a single go. So it's hard to see. So we need to navigate using the scroll bars. All right. So so let's break down the view into three areas of functionality within the show plan comparison window. First, in the upper left corner, or first in the upper left, you have the two plans you are comparing, right? So let me close out this Object Explorer window so that we can see the plan in detail. So all right, so on the upper left corner, or this area basically, this area, we are getting two plans being compared against each other. So all right, so in the upper left you have the two plans you are comparing. So in our case, I'm comparing the execution plan for our query. So let me do one thing. Let me not compare these plans. Let me go ahead and delete that SQL plan file quickly from the SQL Server Management Studio folder. So under Documents, we have SQL Server Management Studio. Under that, we have SQL plan files. So do we see any SQL plan files here? Let's see. Let's do a filter for SQL plan. All right, so we have two files. So we had saved test SQL plan. Let me delete it. All right, so let's do a refresh. So that file is gone. All right, let me proceed. Okay, guys, let me close this, and let's take an estimated execution plan for this query and compare it with against the execution plan with the runtime metrics. So let's take this one, the estimated execution plan for this. So let's click on this. So we got the estimated execution plan. Let's save it. So save execution plan as maybe plan without metrics, without runtime metrics, I can say. Let's save it as this plan without runtime metrics. So I've saved the plan. This is the plan without any runtime metrics. Now let me again run the query, and this time, okay, this button was on, so I'm not sure whether that was the estimated plan, although I had created estimated plan. But let me create it again and save it again. So save execution plan as, let's save it in the same file without the execution metrics, and I've saved the plan. Now let's click on the actual execution plan button and execute this query to get the actual execution plans. Now this plan has runtime metrics. Now what I want to do is I want to compare the execution plan, this execution plan which is having runtime metrics, with the plan without the runtime metrics. Alright, so let's compare it, guys. Alright, so this is the plan with metrics. Let's compare it against the plan without the metrics. So let's do a compare show plan and select plan without the runtime metrics. Now These two plans are showing up on the left hand side, and on the right hand side we have comparison window, right? So this is the top plan, which is the plan with the runtime matrix, as it is denoted by the number of rows. In the bottom plan we are not getting number of rows, right? So bottom plan is the estimated one. So bottom plan property window is showing on the right hand side. That one is without the matrix, and the left one property window is with the matrix. It's for an actual execution plan. All right, so got the idea, guys. So we compare we are comparing in a top bottom approach here. So these plans behave the same as plans anywhere else within SSMS. All right. Next, you get the ability to compare the properties of each operator on the right hand side of the screen. So we can compare the properties. So here we see the runtime metrics are different. So here actual number of rows for all execution is 22. This is for the actual plan, whereas for the estimated plan, the actual number of rows for all execution is 0, because this is just an estimation, not the actual execution of the query, so it doesn't contain any runtime metrics. So cardinality, there's a difference in cardinality estimation. So in runtime metrics, no, there is no difference. So its cardinality estimation is the same. And cache plan size we can check is different, and there are other parameters as well. So the estimated execution plan has taken more CPU compared to what is taken by the actual execution plan, right? So similarly, you can compare the metrics in this way. So we get the ability to compare the properties of each operator, right? Each operator on the right hand side of the screen, right? We can compare the operators side by side. So you can see the properties values that match and that don't match, right? So there are some properties values that are matching. So properties values that are not matching having this equal to symbol with the crossover sign, right? So equal to and a line cutting the equal to sign. So these values are not matching. We can easily identify that. So anywhere we see this not equal to symbol, we can easily compare that those values are not matching. All right. So here, for example, let's talk on compile CPUs, right? So this property is not matching. The actual execution plan is checking 41 and the estimated one is checking 64. So this is not matching, indicated by this yellow box containing the not equal to sign. All right. Now, if a given operator exists in a plan but not on the other, you won't see a comparison here. So for example, in actual execution plan, we have property like maybe we can compare degree of parallelism. So this property is not available for the estimated execution plan. All right. So we cannot compare the degree of parallelism option because it's not available for the estimated plan, right? So finally, at the bottom of the screen, we have the options we can set to control the behavior of plan comparison. So I don't see anything here at the bottom. Actually, I closed one of the windows. So that is the show plan analysis window, which we have closed out. Let's see if we can bring that back. So I had discussed the show plan window in one of my earlier videos, if you remember. So let me see if I can get the show plan window. So show plan compare option. So if you right click anywhere in this plan area, you can get the show plan comparison option. So this is the window I was talking about, right? So this is the show plan analysis window, right? And we can enable or disable the highlight of similar part of the plan. So first area is the statement option. We can highlight similar parts of the plan using this option, or we can uncheck it to unhighlight it. So if we check it, the highlighted parts are showing the areas where the plan is basically same in both the plans, right? The area which is same in both the plans. Now you can also choose to highlight the parts of the plan that do not match. So that is the option. So we can highlight even operators that are not matching similar segments. So these select operators are the ones which are not matching. All right. Rest of the plan is matching, but the select one is not matching. So we can highlight the unmatched part, and it is showing the yellow color for unmatched part and the pink color for the matched part. All right, let's uncheck it. Finally, what we can do, we can choose to ignore the database name when making comparisons. So this is the last option, to ignore the database name when making the comparisons, which is very handy when testing disparate systems. So if we are comparing a plan between from different systems, this is one of the useful option where we can ignore the database name when comparing the operators. All right. Now let's talk about some live query statistics. Let's close this out. So you generally got the idea how to compare the plan. So let me close that out. Let me close this as well and close this. I want to see the Object Explorer. So maybe from where we can turn it on. Let's see. From the view menu, we can enable Object Explorer using the F8 button. So we have Object Explorer now, right? Now what we will work with is, we are working on the live query statistics. All right, so let me mention that out. So this is another tool for the execution plans. So we can take live query statistics or the live execution plan of a query. All right, where the query is executing in the background and you are seeing the plan. So that is the scenario I'm referring to. So let's go ahead into SQL Server. Now, if we talk about the live query statistics, let's go back to Node. So if we talk about live query statistics, this is one additional tool which is available within the SQL Server Management Studio. And this live query functionality basically enables you to see the rows moving through an execution plan in real time. All right. So basically, in the live query statistics, you see real data movement in real time in the execution plan, and it is really useful for those queries that run for a very long time. All right, it's not useful for any short queries that execute within maybe 10 seconds or 5 seconds. So this facility will not be useful. If you want to use the live query statistics, use it generally with the query that are taking longer to execute, so that you can actually see the data movement, right? Also, in order to use it, you have to meet some criteria before you can use it. All right. And in SQL Server 2014, if we talk about, you have to be running an extended event session using the query thread profile event. This will enable the live plan. All right. So I was talking about SQL Server 2014. So and the criteria which is required to view the live plan is, you need to run the extended event session using the query thread profile event in the extended events to enable the live plan. Now with the SQL Server 2016 and 17, you can use the extended event session as well. All right. However, there's a trace flag 7412 that you can set for the server. This enable what is called lightweight profiling. So 7412 is the flag for lightweight profiling. So, and also in SQL Server 2016 and 17, we can use the extended event session as well. But we can also use the lightweight profiling by enabling the trace flag 7412. We can also use the query hint query plan profile to enable it at the query level. All right. So let's talk more about that. So, and if we talk about SQL Server 2019 and greater, as well as the Azure SQL databases, lightweight profiling is enabled by default, and you can disable it at the database level using the database scope configuration change, where we can set lightweight query profiling to off. And because this is a live moving process, it won't show up well. All right. Uh, it should show up well. Let's see. However, I will let's walk through the query and show you how you can view it yourself, right? So let me run a query which I think will run for approximately 90 seconds. Let me just create a query against the AdventureWorks 2022 database. So let me, you may write this query along with me. So let's do a select. For now, let's take star. So let's take select star from sys dot object. So this is one of the tables, and let's take this the abbreviation of the table as O, and select some object. So basically this will make a join in the background, but yeah, it is selecting data from two tables. Let's take O dot star to take all the columns from O table, and let's take O2 dot star to take all the columns from the second table O2. All right. Now, this is a long running query that will run for approximately 90 seconds. So in order to get the live stats, this button should be turned on. So include live query statistics. This should be pressed. So I've pressed it now, right? So let's see. So this is a toggle button, like the actual execution toggle right next to it. So this is the toggle for actual execution, and this is the toggle for live query statistics. Okay guys, so we have turned on the live query stats button, and it's actually like the actual execution toggle button right next to it, and we have turned it on already, and let's execute the query now. So we will get a live plan after that. So in the plan, let me tell you from beginning, we will see some pipes that are solid, and some will be dashed lines, and this, let's talk about the solid pipes, right? So solid pipes represents, let me write it here in the plan itself. So once I execute this plan, what you will see, you will see some pipes in the execution plan are solid and some are dash lines, right? And let me give you the explanation beforehand. Now the solid lines, if we talk about, they represent completed activity, right? So any solid lines represent the completed activity. All right. And what about the dash line? If we talk about the dash lines, they show, they actually show, actually they move and show data movement. All right. So dashed lines move the data as well as show that data movement, whereas the solid lines represent the activity that is already completed. All right, guys. So you got the idea, right? Okay. Let's move ahead. And we will also see some row counts below the operators getting updated in the real time. So what else we will see? Row counts getting row counts below the operators getting updated in real time. This is the third thing we will see, right? Showing which ones are complete and the completion status of those still active. So it will, all right. So we will get the completion status of the row count. So row counts below the operators will get updated in real time. That is one thing. And because what they will show by updating in real time, they show which ones are complete and and the completion status as well for those which are still active. Now at the top left is even the percentage complete readout. So let's see, it will show the progress as well, progress of completion. Maybe I can say percentage progress of completion will show up in the top left corner. All right. So keep these items in mind while looking at the plan, right? This will run for 90 seconds. So you should be able to view the plan for some time, right? All right. All right. We will also get the tooltips and properties to see all the expected details there. But let's for now, let's execute with the live query statistics. Let's execute it and focus on the solid line, dash lines, any row counts, right? And the progress of completion. So execute it, right? So this is the plan being executed right now. This is the live execution of query. Query is still being executed. And we see the progress over here. It's 92, 93% completed, 95% completed. We see these dash lines, which are the operations which are about to complete. They are complete now. So we have solid line now, right? Let me show you again. Let me execute it. Please check you see data movement here as well, right? Number of rows being updated are showing here, right? And the solid lines, which indicates operations that are complete, right? We can see the tooltips, etc., right? And we can see how much each step is complete, right? Not each step is complete, but yeah, overall progress is shown over here. Please watch it once again. So overall progress comes here, right? And these are showing actual stats being getting changed, right? The hash matching is being done, the nested loop join is being done. Some of the operations are not complete, indicated by the dash line. Some of them are complete, indicated by solid lines. Once the all operation completes, they are indicated by the solid dash line. So all the operations are complete now, and we will see that progress, estimated query progress is 100% now. So it is 100% complete now. So this is what I wanted to show here. And all of this is driven by the dynamic management view. sys.dm execute query profiles. All right. So this can also be driven by dynamic management view sys.dm execute query profiles. You can query that as execution plan are running. So instead of using this live query statistics from here in the SQL Server Management Studio, we can also use the dynamic management view, which is sys.dm exec query profiles, and we can query that as execution plans are running. So we can run in a separate query window the query against this dynamic management view to see the live query plan and to see as the execution plans are running, we will see the active row counts same as before. Alright, let's ignore that for now. You saw how the live query plan works via the SQL Management Studio. For now, just keep that in mind. How the stats change, how the progress is showing over here, the concept of dash lines and the solid lines, right? Alright. Finally, you can also simply look at the live execution plans of long running query without having to execute them yourself. So in this case, we have executed the plan ourselves, right? We can also see the live execution plans of any long running queries that others are executing, and you don't have to execute them yourself. But yeah, for those queries, you can see the live execution plan yourself. So for now, right click on the server in the Object Explorer view. So in the Object Explorer view, just do a right click. It is not doing anything. So Okay, so let's see if we get a choice of activity monitor. So we need to right click on the server actually, not in the blank area. It will not give us anything. So right click on the server we are connected to. There's an activity monitor option. Please open that. You will see that activity monitor for this SQL Server, right? So selecting this choice will open up a new window, and in this window you will see a series of overviews of performance as well as processes and the resource rates, etc. Processes, resource rates, right? Okay. And data file IO you can also see any recent expensive queries you can see, and active expensive queries you can see. If any queries that are running which are quite expensive or running from long time, you can see them over here. And any queries executed in past which were expensive. So it is showing us two queries that were expensive. All right. So yeah, you can check that out. And under processes, you see the processes running, right? So we basically see against which database which particular process is running. Maybe a SQL Server agent job is running against a database. We will see all the processes that are running against the SQL Server databases over here, right? Okay. So basically, if we see anything under the active expensive queries, we can right click on that query. So let me execute that query, right? Let's not take live statistics over here. So I've turned it off. Execute that and check that in the active expensive queries. So we can right click on that. We will get a context menu like this. So we can see the show live execution plan from here as well. So this can be done for any queries executed by other users as well. So you can take live execution plan of those queries from here, right? So right now the plan is complete. So it will not show anything as of now because the query is completed. All right. So let me close that. Yeah, but I've shown you the idea how you can take the query plans for queries which are executed by other users, which are long running queries. You can select the show live execution plan option under the active expensive queries. All right. So it will also open up a live execution plan window if the query is running. In our case, query was stopped, so that's why we were not able to see its live plan. So let me run this query again and see if we can get the live execution plan. So yeah, we got it, right? So this section is basically useful in the scenario. So I'm talking about this section. So this is useful in the scenario if queries are executed by other users and you want to see the live query plan, you can do that from here. All right. So that is fine. So otherwise, here what we were doing earlier is we were taking the live query statistics for the queries which are being executed by us. But yeah, if you want to see the query plans, live query plans for the queries executed by other users, you can check it out from here. This is one of the very useful feature, guys. So please take a note of this. This is one of the very useful features. Okay. All right. So this is done. Now, this is a somewhat expensive process and can place noticeable load on the server. So getting live query statistics is a expensive process, right? We can say it is an expensive process. All right. And can place noticeable load on the servers. And we should use it only when we need to, when it's absolutely essential, right? And live execution plans are very useful for extremely long running queries. So let me note that down. So live execution plans are very useful for extreme long running queries. extreme long running queries. So for extreme long running queries, we can use the live plans. Like we can say data loads of certain kind, right? Maybe DB loads to get a sense of their completion. So we can use this live query feature to see how much data is DB loaded in the system. So if we have something like a DB loader, which is reading data out of CSV file, pushing out the data in a particular table and it's taking long to complete, we can take a look at the live view of the data loading process, right? All right. So always remember that the row counts are based on estimates. So if there is disparity between the estimated and actual rows, the percent complete for any given operator or the entire query won't be accurate. All right. All right. So that's it. Now let's talk about some of the third-party tools also available for execution plans. So third-party tools for execution plans, I can say, are also other way we can take a look at execution plans. And basically, we will not discuss in much detail on how to use this tool, but yeah, we'll provide you a brief overview just. So we are merely going to point out how these tools can help you understand and read the execution plans. So some of these tools are, let's say, we have SolarWinds Plan Explorer is one of the tools. So you can use SolarWinds, and another one can be Supratimas, and this is one of the tools. Another tool is Paste the Plan, which is another tool. Each one is having their own website. All right. So let me talk about this tool briefly. So let's first talk about the SolarWinds Plan Explorer tool. So Plan Explorer is incredibly power tool, I can say. So not only will it Okay, let's talk about that Solar Winds Plan Explorer. It's an extremely powerful tool, first of all. Not only will it display your execution plans in a variety of different formats, I would say, but it contains a whole lot of analysis tools that are available to help you better read and understand the execution plans. And some of the analysis can even point you right to where the performance problem exists, as illustrated by the execution plan. And one big option that is available in this tool is the ability to make plan anonymous by removing all the index names, column names, and values in the query. And that basically makes it easier to share plan with others. All right. Now, Plan Explorer, the SolarWinds Plan Explorer integrates with the SQL Server Management Studio as well. So you can't actually replace your SSMS plan behavior with it. However, it is probably the single best third-party tool I can say available for the execution plans. And it is available for free and can be downloaded from its own website. You can check it out on Google. Another tool is Supratimas is another tool. So it's a web-based plan analysis tool, I would say, and it is not as extensive or as vast as the SolarWinds Plan Explorer. However, it does give you some help in looking at the execution plans. And basically, we paste our XML into the web page, and you can then see the highest cost operations in the order format. And you also get the list of operators that are causing IO, again ordered from highest to lowest. And this tool can absolutely make it easier to understand what's happening within your plans. Again, it can be downloaded from its website, which is I think supratimas.com is the website, but you can check it out online. What should be the exact URL for that? Now, another tool is the Paste the Plan tool. This is the simplest of the third-party tools, and this is just a way to share execution plans easily with others. Basically, what we do is we paste the XML of our plan into the web page, similar to the Supratimas, and we can then get the URL to share with others so that they can see your plan in the graphical explorer provided, or they can also download the plans to their machine. All right. So this paste the plan site basically provides the URL for an execution plan which you can share with the other users. Okay. So yeah. Uh, okay. So we were talking that this site basically where you paste the XML to get the plan. You can also get the URL which you can share it with the other users, right? And so that they can see your plan in the graphical explorer provided, or they can also download the plan to their machines. And the graphical plan is limited and doesn't show all the properties though. Um, Also, you may want to use the plan explorer to anonymize your plan prior to posting it on a completely public website. All right. So yeah, site can be checked online for this tool. So guys, we are done with this topic, which was using execution plans to analyze the query behavior too. And what we have learned in this chapter, so there were two parts of this video first of all. So what we have learned in this topic using execution plans to analyze the query behavior, part 1 and part 2 is uh, basically we learned what execution plans are and how we can read them. The differences, we talked about the differences between the execution plans and execution plan with runtime metrics, also known as estimated plans, as well as the compared to the actual plans. So we have execution plans and plain execution plans and execution plan with runtime metrics. And we have established the differences between them. And we also went through the mechanisms for reading and understanding the execution plans. And we finished with some tools that can make working with the execution plans easier. So in our next video series, not series, in our next video regarding this performance tuning series, what we will cover, we will be discussing about the statistics and how they can be used, and we will try to understand the distribution of data. We will talk about the concept of cardinality, and we will talk about the row counts that drive the decision of the query optimizer. So we will talk about all these concepts. So next video will be an interesting video. So you should keep a watch for that. And guys, again, if you have not subscribed to my channel, or if you are new to this channel, or if you are already watching my channel but not yet subscribed to my channel, please go ahead and immediately do so. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. And this is a 5 seconds process, so please go ahead and do so right now. I'm waiting. So alright guys, I think you should have subscribed by now, as I have asked. So it will be very useful for you as you will get timely notification. So guys, we are done with this video, and if you want to share anything with me, you can send me an email on vrmavane@gmail.com. And in case you need the PDF copy of the notes that we have discussed during these two videos, the part 1 and part 2 of using execution plans to analyze the query behavior, in case you need the notes of this video, that will be on a paid basis, guys. Please keep this in mind. The notes will be paid from now, so it will be INR 25 per page for a note. So if it's 4 pages, it will be 100 rupees for 4 page of notes. So in case you need the note, guys, you can send me an email to vrmavane@gmail.com mentioning the video topic for which you want the PDF notes. And upon receiving your request, I will send you the payment link, where after making payment, you can download the notes in the PDF format. All right, so we are done with this. So guys, do share your comments with us. If you like this video, click on the like button below this video. Do share your comments, suggestions, any requirements, any day-to-day stories or experiences with SQL Server, any stories where my content has helped you somewhere in understanding the concept, or maybe you have applied my content practically somewhere to reap some benefits. Do let me know about those situations. I love to read your stories, so please do send them to me. So alright guys, I thank you so much for your time on this video, and you have a wonderful day ahead. Thank you.